control your chest and the contraction of your chest. Okay? Right? You just be here, feeling your breath. As best you can, just focusing all your attention on your breath. Feeling each breath as it comes. Feeling it through the expansion or contraction and contraction of your chest or your tummy. Breath by breath as it comes. Don't need to do anything. Don't need to control your breath in any way. And if you notice distraction from thought and noises, just acknowledge the distraction. Just try not to capture it or turn it into a story. Just acknowledge it and let it go and bring your attention back on feeling your breath. Just this breath, feeling the breath. Just a few deep breaths, few breaths. Just feeling the breath. Okay, I'm going to spend a few moments on feeling, getting your body sensation. See whether you can feel all the sensation from your buttocks. Contact between your buttocks and the seat. You might feel some pressure, some temperature, some softness, hardness. See whether you can focus all your attention, feeling that sensation that your body is sending you. And again, just observing, not trying to fix anything, not trying to process. You don't need to process, just feel. Open up to any sensation from your body. Just feeling all the sensation that your body is sending you. Feel an intense sensation like a pain signal from any injury or anything. Just don't try and fix it. Breathe into it. Just observe it. Focusing on your attention, just observing your body sensation. Okay, I'd like you to be aware that you've got people around in this lecture room. There's people around you. And I'd like you to think about what are you trying to get out of this morning, this 1 hour we're going to spend together. What's your intention? What are you intending to get out of this next hour? Think about it. Think about what's your intention, what you're trying to get out. Maybe even preparing some questions to get what you're trying to get out of this morning. Okay, go back to feeling the breath, just for the last few deep breaths. Breathing in, feeling the breath. Breathing out as it comes. Okay, when you're ready, just open your eyes and come back to me. To the room, I should say. All right, this is a quick, what you call it, centering, grounding meditation to get, our mind away from all that stuff that we've been thinking, back into the lecture room now. So you're aware that you're here in the lecture room in front of you. Cool. All right, so this morning, were you wanting to say anything before we start?
Go up to you.
Cool. Okay, so last week, was there any question from last week, by the way? Any question from last week? All clear as mud. Okay, cool. I used to do some training in China, and I used to look at the room and I'm thinking, oh my God, I'm sure they're not really getting 100% what I'm talking about. So I said, is it clear as mud? And they said, can you translate clear as mud? This is just, can you hear me? Is it working? Is it working? Can you hear me?
Yep.
All right. So last week we talked about what is quality. Quality is more than just, the durability, more than just how long it lasts, but it's a lot to do with what understanding or delivering what the customer is expecting in terms of the product. So this morning I just wanted to talk a little bit about how do you go about finding out what your customer wants. Because in all aspects of any kind of product, typically you get satisfied customer if you're delivering to the expectation. If you're not delivering to the expectation, then there's a gap between expectation and actual performance. Then there's always a gap. And in that gap, a lot of that is to do with quality because you're not delivering to the expectation. So this morning I just wanted to basically talk about how do you define the requirement so that you deliver the quality. Because some aspect of the performance may not be important to people. So if it's not important, then no point in delivering it or getting the best out of that performance because people don't care. People don't care. So, okay, let me start with taking some pictures. So if you're designing a product for quality, how do you account for this? Okay, you design a product and people overload it. Okay, so is that poor quality? What do you think? Is that poor quality? No, it can't be, because that's abuse, really, right? Because you can't. But however, having said so, if your product is going to the market where this is very regularly done, you're selling in the market where they carry a lot of people, okay? Then you need design to the market. So it really depends, right? In Australia, this doesn't really happen. So if you're doing the Australian market, you don't have to worry about it. You go into Africa and lots of places where if they use this like this, then you need to account for it. It's a question of how do you know what the customer is looking for, that you're not specifically focused on the wrong market, on the wrong customer base. Okay? Trailer tow. Has anybody seen this elephant? Okay, so you design your trailer tow for, I don't know, 1 ton or 800 kilograms, and somebody puts, a tow behind it. I guess what happens. So it's a question of how do you design to capture this? In that situation, what would happen if this thing crashes? What happens? Okay, and say the guy who is driving is going downhill or uphill, and the tow bar gives up. Okay, and it causes an accident. What happens? What will happen? Where's the liability? Is it the company's liability? Is it the driver's liability? Whose liability is it? The driver's liability? Okay, different opinion. Manufacturer's liability? Actually, manufacturer becomes the engineer, right? The engineer hasn't designed it right. Because really speaking, it's very, very, and I'm not trying to frighten you, by the way, but I'm not exactly sure where the legal accountability stops. If you do something negligent as an engineer for a company, is it your responsibility or is it the company's responsibility? I would have thought it'll probably be the company's responsibility, but you probably get a sack for it. But in this situation like this, has people heard about Australian design rule? Yeah? Now, if you meet with Australian design rule, okay, to say that this tow bar is only capable of towing 1,000 kilogram weight, and the guy put 3,000 kilogram weight, it breaks, then it's his fault, in a way, right? But having said that, if they're clever lawyers who takes you to court and says, well, no, that's not abuse, this is normal use, because a lot of people tow more than this expectation. It depends on the way it is. Okay, the ADR could say 1,000 kilogram, you need to put some safety margin in there, it takes you about 12, 13 kilogram. But if it's within that range, like 15 kilograms, just a little bit over, how do you argue it? Some clever lawyer might say, well, okay, within the realm of, error or whatever. But so you need to be aware, right? How do you cover yourself as an engineer to not run the risk of either causing a bad accident or being legally responsible for not designing the stuff that the market is expecting? So there's regulation involved in that. What happened to this thing here? But from an engineering point of view, what is happening here, by the way? What's the biggest risk in here? The center of gravity, right? It's changed the center of gravity, and if there's a side wind, or it's going around the corner, it's going to topple over, right? In fact, SUV, one of the biggest problems we have with SUV is center of gravity, that they topple over very, 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 very much easier than car. So there's lots of accident and lots of fatal casualty out of SUV toppling over, losing out of control. And guess what? Do you know what we've done? Anybody knows what we've done to try and minimize the risk of toppling over? Anybody knows? Has anybody heard about vehicle dynamic control? Yeah, where essentially there's a safety system that senses if you're about to lose control, it actually applies a brake to keep you in control so that you don't get into the what we call vehicle dynamic instability to get you topple over. A lot of the SUV now have dynamic control. Bosch, anybody from Bosch? No, Bosch. Bosch pretty good at selling that system, and most vehicle. In fact, the government at one point was talking about making it regulation that vehicle dynamic control should be part of the ADR, a requirement for the customer, for the vehicle manufacturer. So that's kind of the, I mean, but again, it's a question of what I'm trying to do here is for you to remember these pictures, right? That you need to understand what is it that the market is looking for, and how could you minimize the risk of causing problem. Okay, here we go. I don't know. Where's that? Who's from India? Anybody from India? That's probably not happening now, right? I don't know who's taking that further, but this is like if you design all this train, I don't know, how do you deal with this? Yeah? Well, there's a couple of things, the train and the bridge, right? Okay. All right. So I wanted to basically talk about how do you, what's the process of the product development process in essence, in a very holistic way. As an engineer, as a process in product development, there's essentially, at the very high level, almost like three or four phases, if you want to call it that. The first phase is really, if like you coming up with a new product or you're changing your product, the first thing that you have to do is to define customer, who's your customer base, what is it that they're looking for, okay? In terms of, let's say, for the vehicle system, okay, for the motor vehicle, you need to understand who your customers are. Like Ford, right? Ford has got a certain follower, certain type of people who would buy Ford. Typically, it's family, you know, people who like performance. Car needs to be affordable. So you don't go and target the BMW customer, right? Like the luxury, you know. So you need to know what's this cohort of your customer you're looking for. Or, I don't know, let's say you're selling a product that's really appeal to the younger generation, or whatever generation, X, Y, or whoever. You need to know who you're targeting, right? It's no point in just saying, okay, statistically, we just get a random sample of the population and just work on it. It doesn't work. You need to understand who's your customer, who are you selling to, who's the base, who are the people who's buying your product, who are the people who's likely to buy your product. So then you understand who's your customer. And then, having understood who's your customer, you need to go and find out what is it that those customers are looking for in the product that you're trying to sell them. And that has got, you know, different ways. You either do some research, marketing research. We used to use a lot of focus group. People don't understand focus group, where we just recruit people to come and talk to us, especially people who are in the population of the customer base, come and talk to us about, you know, what kind of product, what kind of features they like, what is it that they don't like, all that kind of stuff, just to get a bit of a feel as to what the customer base is thinking. Okay, so the first aspect of it really is defining. Now, when I'm saying defining here, I put customer here, but really the define phase encompasses not just the customer, but you start with who's your customer, what they want. And then once you've done that, then in the product that you're trying to produce, you need to define how are you going to deliver those features? How are you going to deliver functions? Okay, you know, what type of material you're going to be using, what size it is. You know, in a car it'll be how many seater, what size engine, you know, what kind of entertainment system, what safety level we're going to have. All that is defining. We haven't even done the engineering yet. Okay, so one of the things that in terms of the process is that you don't want to spend a lot of your engineering resource working on the product when you don't even know what you're designing for, because then you're just burning resources, you're burning money, you're burning you know, effort. Because if you're working on certain function or feature and you find out that first you're not, it's not affordable, it's not part of what you're trying to sell, you're wasting time. So it's always the first phase is really defined. Clearly, engineering is also involved in the define phase because they need to, when the ideas are coming, talk about, well, how are we going to do this? Is this possible if we're wanting, you know, I don't know, karaoke in the car? Right? We like singing, right? We want to do karaoke whilst we're driving, okay? How are we going to do this? Is the technology available for us to do this? Okay? Or is it going to be visual? Is it going to be just sound? All that stuff needs to be defined, and the engineers needs to be there to define how we're going to do it. Because if you can't do it within time and cost, you just don't do it. Let me say, anything can be done. I said last week that the function of the engineers to turn dream into reality. I think any dream can be turned to reality. It's a question of whether it's affordable, can be done within the time frame. So you need to decide, the engineers involved in the define phase to define, is it feasible, not feasible, but you need to understand that you don't start working on it yet. Okay, so that's basically the define phase. Questions on that? No? Clear as mud. No? Come on, I'm not going to talk the whole hour. Anything that you want to clarify? And let me say, it doesn't matter whether you're designing a car, or kettle, or microphone, the process is very similar. It's just that some are more complex than others. Okay? Define the customer, define what they want, work out in terms of what they're looking for. Can it be engineers within the time and the cost, and engineering point of view? That's kind of like the process.
When you find a feature that doesn't exist in the market already, do you then, it's quite complicated, do you then break it off to a separate research group?
Okay, let me just say, okay, in Ford, like for instance, right, the various entity in the product development, there's a research group that is looking at transforming dream into reality. So they're in research phase. They're not ready for production yet. In production, it's not very often that we're going to research. It's more adapting what's already been engineered to fit in the product. Because you can spend a lot of time inventing. That's not the purpose. Even people who go into research and inventing is a phase of engineering. In fact, well, kind of phase of engineering. But it needs to go through a process of study to see what is feasible, whether there's a technology, whether there's a material, whether there's a design that can make it happen. We don't spend a lot of time on that. There's different department that does that. In product development, it's almost like you need to adapt what's already existing, put it together into a product that works. Otherwise, you just won't make money. It's just too expensive. You just rely on other people, you know, university, research entity, and other competitor, like Ford, Toyota. If you're smaller car manufacturers, you'll see what they're doing and pick up what they're doing and convert it into your product. Yeah? Yeah.
On that.
Yep.
On Facebook, as I am,
Yeah.
I'm in one of the nerdy groups
Yeah.
that has videos of
Yeah.
manufacturing processes.
Yeah.
And there's a Mercedes one, it's really nice, there's a
Yeah.
BMW one. And I look at it because there's an awful lot of invention in the manufacturing process itself, the design of the manufacturing process.
Yeah.
And I've spoken to the class about design, leading manufacture, and
Yeah.
such things.
Yeah.
But to BMW, Mercedes, the boutique companies can perhaps afford to do
Yeah.
invention phase. Does Ford?
Well, it depends on what you mean by invention. It depends on what you mean by invention. We're more converting ideas into practicality, manufacturing capability. Now it's like you know, the printer, the 3D printer now, right? Is that if we're going to convert that into producing a part that's totally uniquely automotive, is that invention? No, it's an adaptation, right? We're not inventing the 3D printer. We're adapting it for our purpose. Or, I don't know, in the exhaust emission, right, there's some catalytic converter and, you know, material. There are people who's looking for better material to treat the exhaust emission. Now, that's not invention. That's like really adapting again. It's engineering it. It's like gray in the area. For me, it's more definition. What do you define as invention? What is it that,
Someone
you know?
invented ABS and someone
Yeah.
vehicle dynamic control.
Yeah.
And
Yeah.
that's the boutique end of
Yeah.
where people want that.
Well, it's not even inventing. Well, yeah, this is the problem, right? This is my definition. Okay, all right. Somebody in the vehicle dynamic thing would say, okay, there's a problem where every time we press our brake, the car gets out of control and skids, right? We need to fix it, right? The engineers goes into solving the problem, right? So it's not an invention. Why is it slipping? Okay, because the coefficient of friction, once it starts to fix, just let you go. So how are we going to stop it getting above that coefficient of friction, right? And somebody comes up with the idea, okay, we're going to modulate it, right? Now, this is really invention, but it's more invention in a practical term to fix a problem, right? I guess the reason I'm saying is pure research where you come up with totally, but even that, you'll go to the patent shop, you'll go look at all the ideas and see what you can use, and then you can have to pay the patent owner some money for you to use the idea. I don't know, it's just semantic, really. But engineers is mostly not working, unless you're specifically in research, in industry, in manufacturing. You ought to convert what you use your engineering knowledge to convert things into a product. If you spend a lot of time into invention, yeah, you go and patent your idea and then you get money for it, but that's not really manufacturing and selling a product. You can spend a lot of time, because you can't afford time. You just need to consolidate the idea into using existing technology to make it work, is where I think you want to focus if you want to make money and make a success. Unless you're in the research department or CSIRO or come to Ford and works in the research department specifically in the invention area. Even that takes a while before it goes to the production. All right, so the second one really is that once you define the customer, you define what they want, you've said from an engineering point of view it can be done, how do you go about engineering it now? So that's kind of like the next phase. And engineering it really is where you use, again, existing technology, convert that to deliver the functions. And most important aspect of delivering to customers' expectation is that the engineers tend to think in terms of technical output, technical performance, input-output from a technical point of view. And that's all very well, but a few years ago we decided that, and we found that the customer don't understand technical output. They more understand feel, kind of like, if you working in audio entertainment system, okay, you're not talking really about, oh, this is really good, it's got 80 dB, blah, 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 right? The customer don't understand. It's a question of how does it feel when customers listen to it, right? How does that feel? So we convert really, again, even from an engineering stuff into what we call attribute, okay? And then the engineers in its own world, not talking about a customer requirement, its own world has to convert that into engineering metrics, measurement. But when you're talking about delivering to the customer, you always think about attribute. For instance, in the vehicle, we talk about performance attribute. How does that feel? Does it feel powerful? Does it get quick response? In terms of the seat, is it comfortable? You're not talking about pressure distribution on the seat, right? You talk about how comfortable does it feel? NVH, how noisy it is. So it's always discussed in terms of attribute. And then from that attribute, that gives you some sense when, as an engineer, you convert the attribute into engineering measurement to determine whether you're meeting with the customer requirement. Yeah, I'll give you an example. Say performance field, for instance, right? So typically performance field could typically be measured in terms of how many seconds it takes for your car when you put your foot right on the floor. How many seconds does it take to go from 0 to 100 kilometers an hour, right? Performance field. When you put your thing in here, how is the takeoff, right? So there are a number of, or how's the acceleration kind of stuff. So in terms of attribute, you need to think more about that's a feeling that the customer is getting instead of, my vehicle is able to produce 110 kilowatt, it's got a torque of 320 Newton meters. The customer really, unless you're really kind of like in that zone of following all the kilowatt, all the torque and kind of thing, most customers probably don't. Okay? Now, unless you're specifically in that racing market where you know your customer likes this, then you go and focus on it. But mostly, you know, yeah, kilowatt and Newton meter may not be what your customer is looking for. So you need to convert the whatever you're working on in defining what you need to deliver the functions in terms of how the customer feel about it, okay, at the end. Okay, so then you go about designing the product, and even in design phase, now we use a lot of CAE nowadays, right? A lot of CAE to try and minimize the amount of hardware and prototype that we need to make to be able to see whether that...
Computer-aided engineering.
Yeah, CAD, computer-aided design, or computer-aided engineering CAE to basically look at the design as we're doing it and even kind of like dynamically test it and see whether it's going to work. So we do quite a bit of that. And then once that design phase has gone through, we need to test it. We've designed the product, test it, and then we're ready to go to the manufacturing phase. Okay, so that's kind of like the various different phases of what we go through. Okay, so I'll just give you a very high-level picture of what I did. I'll just go through a few of the slides just to reinforce what I've talked about with you. And if you want to ask a question as I'm going through the slide, please stop in. What's time now, Colin? What time is it?
Oh, it's now
1:30. Okay, good time. So I'm just going to quickly go through the slide and then stop me, and then we can talk about that.
What software package do you use
For CAD?
Yeah.
I don't know. I don't know.
You have minions for that.
Sorry?
You have minions.
Oh, yeah. No. Well, yeah. So I don't really know what's the latest package because I don't get involved. If I want anything designed or drafting, I go to draftsman or the designer. I say I want this drawn. I don't get involved in the stuff, and I don't do much CAD myself. We have got kind of like we've got CAD system that allow us to change stuff, look at stuff as we're designing it. But this is somebody else's job. Yeah.
Unique graphics is what another Ford person told
Yeah.
me a few years ago.
Yeah. So I wouldn't know the detail. Yeah. Okay. So voice of the customer. Essentially, what this picture is trying to show is that as we go global and region, we need to make sure that we define what the different market is looking for. And somehow, if we want to have just one product for the whole region, we need to basically segment the product in terms of what are the common regional expectations, and also define what are the unique requirements for each of the market. And we talked about horn last week. We talked about the flasher. We talked about the auto thing in here. So basically, to minimize cost, you need to, if you cover a lot of market, what are the common expectations? So that's all on the platform. And what are the unique things? So you need to then decide what you want to do. But it's important not to fall into the trap of designing something for Australia and go and sell it in India, because it's not going to work. Well, it's work, but it doesn't have any robustness.
Could I ask you to just spend a few minutes on what, many years ago, when Ford Executive International made that decision and some of the benefits and issues associated with what Ford did?
Sure. Okay. So let's just talk a little bit about our own experience in Ford. I mean, primarily Ford was just Europe, North America for a long, long time. And then we decided to expand into Asia. Australia was one of the market. And we had basically a unique product in the Falcon range. Okay. Well, firstly, having a unique car line is not economic because it takes a lot of money to develop a car. It takes, I remember when I was in the program, it was like $350 million to facelift the Falcon. Okay, 350 million. Okay? That takes about 3 to 4 years. So you think that's a lot of money to spend, and to get the return, to get the profit is pretty tough. It's much easier to pick up the Taurus or the Mondeo as a platform and convert it, adapt it for this market, okay, to try and accommodate the uniqueness of what this market is looking for. But that's one aspect of it. So you need to share a platform. The other aspect of it is that when we decided to import, you know, the laser or the Escort into this country, the car fundamentally is not designed for this kind of market. Like, for instance, right, if we export the Fiesta or the Escort, as it is designed in Europe, it overheats. It overheats in India, okay? And people complain that their conditioning is not working good enough, okay? Because you think about the condition that they have in Europe, they never have to have, 35, 40 degrees continuous temperature, right? So when we bring the product into the market, because there was so much rush into getting the product in the market, there was not enough adaptation done to accommodate that particular market. Other stuff like horn durability we talk about India has a lot of flood, monsoon season, and we were having problem with, water ingress into the vehicle. So all of that stuff, which goes from market to market, you can't simply take a product that was designed for a certain market and plunk it in a different market and expect it to work. It just does not work that way. So that kind of like we learn very hard in that way, and this is what I'm talking about in this situation. Firstly, you can't afford to design a unique product for the unique market because you'll lose too much money. The competition just don't work that way. In fact, Toyota is very good at spreading the range across all different markets, and I guess we've learned from Mazda and Toyota. But you need to decide what is common all across all market, what is robust across all market, and what are the unique adaptation you need to do to be able to put that product in the market. So that kind of like what experience. Is that what you're asking, Kevin? Yeah?
The Ford Australia closure is part of that, too many factories, too small.
Too many factories, too many. You need, I think, on the automotive industry, we were talking about at least needing to produce about 100,000 units per year to make us profitable. Now, we took that down to something like about 60, 70,000 because of efficiency improvement, automation, and that kind of thing. But still, we don't have that volume now, so you can't. What we were trying to do is to try and build a focus for the region. But in that time, because of the exchange rate, because of the labor rate, it's just not competitive to do it. The other thing you have to realize is that we're in a global market nowadays, the regional global market. Have to be competitive. You need to use your strength and be able to compete. If you're not, you just die. But having said that, though, the demise of the automotive industry, for me, is not purely financial. It's not purely economics. Because the automotive industry is a very strange animal. Every country who's got a manufacturing entity in the world has got some level of subsidy from the government because of the potential employment that it produces. I personally feel that the demise of the automotive industry was that there was not the political will to support it, one aspect of it. The second aspect of it is that when, was it Kevin Rudd? Kevin Rudd was talking about, the impact of the automotive industry having on the CO2 emission, the fuel, and all that kind of stuff. I think that changes the culture, the expectation of the people that big car is too wasteful. Now, that's not always true, by the way. If you think about the impact of the difference between a Falcon and a Camry or even a Focus, the difference in fuel consumption is not really that great. It's not where the problem is, but that's how people see it, because it's been marketed politically and the press, and so marketing's got a lot to do with it. So people stop buying big cars, okay? And that even didn't make any sense from a marketing and customer requirement point of view, because Australia's a big country, right? You drive from here to Sydney in a Falcon and you drive one in the Focus, you see the difference, right? It's just, we were surprised. But having said that, the US is still having big cars, big truck, so it's a question of where the market, where the culture, where the attitude is going in the country. And you need to understand all that stuff to be able to work out whether your product has got a place in the market or not. So but it's not the engineer's job, really. But, okay. All right, voice of the customer, and you can see in here, we're taking input from all different markets, New Zealand, China, Taiwan, Malaysia, Vietnam, all these places is where we identify what is the common expectation, what are the unique expectation, and before we go and define the product, if you like. Regulation, I talk about the turbo thing. clearly each country has got their own sets of regulation. Now, that's not negotiable, by the way. You can deliver a poor feature to the customer. You cannot infringe regulation, because if you happen to put into the market a product that doesn't meet the country's regulation, then soon as the authority finds out, or soon as there's a problem with it, you have to recall your whole line of product and fix it. And that's very costly, because every campaign recall, I think a minimum $1 million for us anyway, in the vehicle industry. Any campaign recall, at least $1 million, but typically it's around between $1 to $5 million anytime you do a campaign. Right? So that's big money. So you need to be absolutely sure that when you're designing your product, what is the regulation that govern your product so that it's either safe or what? Mostly safety, I think. So you need to understand regulation, non-negotiable. Okay, that needs to be an input. And then there's a corporate requirement. Every company, every product has got their own corporate requirement on the product. We call, people heard about the DNA? The DNA of a product. Anybody here with DNA? Right? DNA of the product, and I don't know what DNA stands for into the physiological whatever. But DNA is essentially what makes your product different, more attractive than the competition. Because you need to be able to differentiate your product from other competitors. Otherwise, what is your leading and competitive edge? So as part of the product, normally each company has got a kind of like what we call a DNA in the product. Like Ford used to try and focus on DNA in terms of, right now, our big DNA is fuel consumption. We want to sell ourselves as being the most economical vehicle on the road from among all the main manufacturers. And this is trying to tap into the environmental, the CO2 emission business that if you look at there's lots of money being spent on engine and friction and weight to make us the most economical car in the range. So that's what part of DNA. We used to have part of our DNA performance in Australia. Performance was DNA, and safety. Even though Volvo was supposed to be the safety leader, Ford wanted to be as part of our DNA to be able to say that our car is safer than GM or Toyota or whatever. So you need to, if you're designing a product, you need to look at fundamentally what are your core DNA that differentiate you from your competitor. Okay, so there's essentially three aspects. First one is what is the customer looking for in that product range? What regulation do you meet? What is it are you going to differentiate yourself versus your thing? So that's a corporate requirement. Plus also, the other aspect of the corporate requirement is how much profit you expect to get out of it. So you promised the investor to have a 10% return on investment. You need to meet with it. Or maybe you've been able to sell that to investors at 5% return. So you need to understand what financial commitments. So the corporation has got a certain objective it sets onto it.
I've spoken to the class about VW, for example, brands and what they do. Yeah. And I just put it to the class that these days, I look at even the symbol, VW, I think cheat.
Cheat, yeah.
So I can imagine VW is in a dire strait with their DNA right now.
Yeah.
Do you have any thoughts on that?
Well, yeah, but it depends on how deep your pocket is. In that sense, I mean, VW is a very successful company, very reputable for quality. They've just made the wrong call. A small group of people maybe has made the wrong call, but that's the other aspect of it. It's almost like every company needs to have a good reputation, especially as a corporate citizen. And that's really so important because that's the only thing that you've got which is of real value. Especially now, our world now, where this social media can kill you. I'm not sure whether you heard about the problem some of the company, American Airlines had. What's his oh God, sorry, it's too early. It's too early in the morning. What's the taxi? The people who's competing with the taxi now? Huh? Yeah, Uber. Uber had a problem, right? Because they were tied in with Trump, and people was actually stopping using their service. Okay, because the Uber CEO agreed to be on an advisory board to Trump, and the people in the U.S. says this is rubbish. He's a crook. Okay, I'm not gonna. If you associate yourself with it, I'm not gonna use. So in fact, out of that, one of big Uber's competitor just grew out of it and picked up a large portion of the business. So corporate, kind of like reputation is very important. My response to VW is that I think they've got enough deep pocket to survive the shift in reputation and image. But the funny thing is, in our world, you've always got a short-term impact. It's a question of whether you've got the deep pocket to survive it. And probably in about 3, 4, 5 years' time, everybody's going to forget it. But having said that, though, what is done to your company, though, is ruin it in terms of its future projection. You think if VW didn't have all that problem, how much more money, how much more product that we're putting in there, and how many jobs would have been lost out of this, because loss of job loss. So it's very important to, in our world, to not cheat, okay? Not cheat. You have to make sure that you're transparent, that you don't cheat. And if you made a mistake, people will forgive you. But if you're cheating them, people won't. So it's very important. This is kind of like not new. I remember when the emission control system used to come, there was actually an incident where Chrysler was cheating. I don't know whether you know this, but when we do emission testing in the lab is always done with the bonnet open. Okay? And initially, to overcome the regulation, what Chrysler, I'm pretty sure it was Chrysler, was doing was having a switch to detect whether the bonnet is open or closed. And the calibration that they were using were different when it was closed, and they got caught, right? It's crazy. Don't even go there because it's not worth it. It's not worth it. Yep. Okay, so customer, who's your customer? The other thing that I want to point out is that if you're in the product side, you need to continuously update the customer expectation because it's very dynamic. From year to year it changes. Don't think that, I've done my research now, the customer is going to stay stagnant. It doesn't. It shifts all the time. So every time you're doing an upgrade, you're doing a freshening, you need to make sure that you track your customer. You can read through all this stuff. Kano model, do you go through Kano model?
I've introduced it.
You introduced it, but okay, Kano model it's kind of like invented by Professor Kano. And what he's trying to highlight in here, in terms of quality, there are 3 categories of quality. One which is called basic quality, one which is called attribute quality, and one which is called surprise and delight. So performance quality, if you want to call it that. What it says in here, if you look at the red line in here, is that if the function of your product, one aspect of the function, the feature of your product is basic, people expect it to happen, not to fail. It doesn't matter how much more improvement you do to it, it's not going to raise the satisfaction for the customer. Okay, it's a little bit like nobody says, oh my God, I'm turning my steering wheel, the car's turning around. Right? You expect it to turn, all right? When you put the foot on the brake, you expect the car to stop. So that's a basic quality. It's essential. People expect this, right? So that's basic quality. It doesn't matter how much, whatever you do with the steering wheel to a certain extent, other than feel and how. So it depends, right? But there are certain basic quality that will not increase your satisfaction. However, if you look at the attribute quality, like seat comfort, you look at the sound quality of the audio system, that varies. The better it is, the better the satisfaction is. So this is the straight line in here that says, in terms of the attribute quality, you need to put some effort to make it as good as you can. And then there's a third category, which is called a surprise and delight, where there are certain aspects of the feature that people were not expecting. This is not so much inventing, the new stuff that we put in our product to excite people, right? If you look at iPhone. Every time they come out, they want to give you a few surprise and delights, something that you didn't expect. It's like, you know, the touch thing here on the iPhone. So you need, in terms of defining where to put your effort, Kano is very good at defining how much and how much effort you need to put on there. What is it? Having said that, though, I am not suggesting that you ignore the basic quality, because if the basic quality goes bad, your satisfaction goes down very quickly. Okay? You need to make sure you maintain it, don't put a lot of effort in doing it to a point where it's not relevant. Customer changes over time. Okay, I mean, aging population, right, in the vehicle. Ingress and egress, getting in the car and getting out of the car is very important, right? So you need to understand what is your market. If your market is the aging population, you need to account for it. So you need to understand regulation we talked about, corporate input, DNA, standard, reusability, all that kind of stuff. We talk about attribute. Really, we talk about not for our translation of what the customer is looking for. It's not engineering measurement. It's more attribute. So we're talking about NVH, performance, fuel economy, safety, and cost. All that is defined as attribute. Right? That's how the customer sees the product. Yeah. So NVH is noise, vibration, harshness. It's almost like if I sit in the car. Next time you sit in the car, oh, please, no, I'm not going to tell you this. It'll drive you mad. But anyway, so it's a feel, the vibration, right? So it's like when I'm sitting in the car in here, how much vibration is coming through the seat? Okay, how much am I seeing? All the vibration, the feel, it's a feel and here, really. So this is NVH. The reason why I hesitated is that sometimes we're impervious about some other stuff. But once somebody tells you, you become obsessive about it, and every time you sit in the car, oh, has this got a good NVH? And it frustrates you like hell. Right? It's like somebody says, oh, do you hear that buzz from that neon light? I didn't even know it was there, and now I'm hooked onto it every day. I go, my God, I can't believe this bloody thing is buzzing, right? So be careful, right? Don't cause your own suffering, right? So that's why I was saying. But NVH is noise, vibration, harshness, in terms of attribute. Okay. Just show you in here how do you cascade basic attribute into actually engineering speak. So like performance feel, this is an attribute. But from an engineering point of view, you need to cascade it down to an engineering metrics measurement. And in there, clearly performance feel has got input into it, which is determined by the pedal effort, pedal ergonomics, pedal travel. Also, it's affected by your shift quality, your shift timing. It's also affected by the sound you hear when you're driving the car. So when you start to cascade it down here, then you can cascade it down, for instance, in terms of traction force, weight, engine torque. So that's how you cascade attribute into actually engineering speed. Okay, and compatibility and balancing, always, you can't afford to do everything. You don't have all the money, you don't have all the time. This is why it's so important to understand from a Kano model point of view, what is important, what isn't, so that you can do this trade-off of balance, because you can't give everything. You only got so much budget to spend on your product to make money. So sometimes you might have to trade NVH versus seat comfort, whatever. So there's always a balancing act that you go through all the time. So system engineering, this is the cascading. Basically, engineers work at component level, right? We don't work at system level, but it's always important to understand how does the component add up to drive the system. Okay? So typically we start with the attribute, system, and then we take it down to the component. Like, for instance, if we want to have a certain kilowatt or certain torque, we need to take it down to the intake manifold, what size, what shape, and that kind of thing. So you only work at component level. So you need to understand the attribute, the system, and then down to the component level. That's what we work on. But it's very important, as you're doing this, to understand how, when you're designing component, how does it interact at the system level. Okay? So for instance, total vehicle, you come to the, so you're talking about performance here. If you think about total vehicle performance, what powertrain I'm going to have, what engine size, you come down to cylinder head, intake valve, exhaust valve, down to the component, always cascade down. Reliability versus robustness, I thought was very important to quickly go through this. Quality cannot be maintained unless you design a robust product. Robustness is very important. Robustness, when I say, how do we define robustness, by the way? How long have we got now, Kevin? Colin?
A minute.
1 minute, okay. Robust. I'm conscious of time. Robustness is really defined as your product needs to be able to perform as good in any kind of environment that is put into. Okay? One typical example of lack of robustness is what I was talking about, where you take a car designed for Europe, you put it in India, it doesn't work. That's not robust. It works, okay, in Europe, but it doesn't work in India, so that's robustness. So just wanted to talk, but all right. So it's very important to go into robustness. Just wanted, so yeah. So this is kind of like a stupid, this is not robust design, right? You've got a gate in here and everybody can drive around it. Or this one, you see this one? Can you see this one? This is not robust design, right? You got this helmet, and clearly, if she falls, her nose is gone, right? So she's able to put the helmet the wrong way. Now, as an engineer, you would say, no, that's not possible. It's not possible to design in a way so that it's only fit the head in one direction. But I bet you can. Trust me, you can. If you got a good design, she wouldn't be able to put it on her head like that. Okay? So that's kind of like robustness. You need to. Okay, I don't want to go through this one here. All right. Okay, I'm just quickly through this. Robustness and reliability, years gone by, used to be about testing for failure or testing part using random sample with a big enough size to be able to see whether your product is delivering its performance. But nowadays, we just don't have the time or money to do this, right? Because firstly, in any event, it's very hard before you go into production to get a random sample. So the way we're moving to is now failure mode avoidance. We need to look and think about what's the minimum, what are the potential failure and design against it. Okay, so that's worth seeing. But in here, this was more a question of variability. So in here, I'll just give you a story. If you're the soldier here, you've got two riflemen, one who shoots, what was it, 10 shots or something? Let me have a look, it says. Okay, the data. Okay, rifleman took 22 consecutive shots in ideal condition, no wind, and hit bullseyes, all 22 times. Second rifleman takes 3 shots through physical demanding day in worst case condition, sun in his eyes, but doesn't hit bullseyes, but on the target. Who would you choose which rifleman would you choose if you were that soldier? Number 1 or number 2? Number 2, because the number 2 is designed for failure, right? Sun, wind, he still perform. Might not be perfect, right? So don't look for perfection. It's kind of like say. All right, I'm just going to leave it to there. Any question? All right, cool. Next week, if you want to hear about mindfulness, come to the class. Get up early enough. Cool.
Thank you, Philip. And thank you very much. For those who are here, I'll say this again to the class, but next week when Philip comes, it's not, this is, Philip, that is a session that will not be examinable. It's for your benefit. And just by way of thinking, oh, I don't want to cover this wanky thing, Philip does, it's essentially corporate mindfulness. Philip has taught mindfulness in a week-long session to the whole executive of Ford Australia. So this is, a future, a opportunity to maximise your efficiency as a worker. Get that brain working as efficiently as it can. So, is that a reasonable add?
Yeah. It's training your brain for it to manage your emotional suffering and also to try and make best use of your CPU here. Okay, that's all that's about really. It's very simple, but it's either you know it or you don't know it. Cool. All right.
Thanks, everyone. I'll see you tomorrow. Log out me. Put that in there.